Let's see here. I never use that screen, dude. I'm not good with introductions. I just started the damn thing. Nobody's going to be here anyway, so it's just us hacking for 2 hours. This is the way I like it. Good to have some fun here. Record some video. Somebody shows up, whatever. Oh,
the coffee.
Allie's got a podcast tomorrow.
This one, yeah, it's releasing.
Oh, it's releasing.
Mm-hmm. Good episode too. Cool guest.
That's cool. I don't know if she has what she has left right now on the list because I just started throwing away the emails.
I think there's 2.
I told her to find her own guests at this point.
Yeah.
Find people you want to talk to. What do I care? Like, you know? Especially since the emails were coming in and then they were ignoring you guys.
Yeah. That's true. Yeah, there was a lot of them that were just like...
I know. Like, you're not reading your email or something? Or you didn't... I don't know.
The agents managing their emails weren't doing their job.
And it's crazy that these people hire these companies to find them podcasts. Like, our podcast is fairly useless. I mean, what the hell? Like,
it's more for fun. Like,
if you're coming on our podcast to practice, well, that's a waste of time because we're not letting you do any marketing pitches.
Yep.
And if you're coming on our podcast to get exposure, that's a waste of time because
it's not really exposure.
What do we get? 100 people? I mean, I was doing it for fun. I was just burnt out. What happens to me is it becomes a scheduling. The moment, like, I have to do it and I can't do something else that I want to do.
Yeah.
I don't want to do it anymore, right?
Yeah.
And after 3 years, that's kind of where I got. Just when it was picking up some momentum, though.
It was a lot of... I think we're at 150 episodes.
Oh, no,
just
I
about.
did it for like 3 years. What the hell?
It's a lot.
So, Allie's... It's all practice. It doesn't matter what you're doing. You have to practice. So she's getting better.
It's good. I like hearing the stories. It's good. It's good background.
The story started getting boring to me. Like it was. I started feeling like it was the same story. It's like everybody has the same story at some level, right?
Yeah.
It's just a matter of how ignorant and or dumb were you as a kid to take bigger risks, right?
Yep.
Like that's what it is at the end of the day, you know.
Yep.
Ignorance is bliss kind of shit.
Yep.
But I felt like the stories got, I don't know.
A lot of them did have, like, there would always be a few that would be like completely oddball. Which
was good. And then, you know, I don't want to be pulling teeth anymore to get a story out of you, right?
Yeah.
So, but whatever, dude. 3 years, got burnt out. So let's see how Allie does. No reason shutting it down if she's going to do some shows. Plus, with 150 episodes, you can recycle that.
Oh.
No, there's shows here that nobody's heard. You know, you have to recycle.
There's endless content there.
Okay, I'm assuming we're on. So.
Yep.
It's been a while since I've been here. I've been working incredibly hard on Kronk. We're up to release 1.24.4. And when I was in the Czech Republic, I had some major breakthroughs with the code. So I've learned one thing now writing a model server and a model SDK. The template is everything. So I wrote a new Jinja package because the one that we were using was just a mess and I just couldn't take it anymore. Plus, the system wasn't going to be viable if I had to go in and make sure that templates were right and settings were right. Nobody could use it because now you try a new model off a Hugging Face and it doesn't work.
Yep.
So I knew that we had to make sure that the chat templates inside the GGUF data worked. And if they didn't work, we had to wait for a fix. You could always override it, but nobody's going to do that. And then the settings themselves, right? Like, I can't rely on you to put the right model settings in. We needed a way to calculate what the settings needed to be. So I did all that work. So we're at a point now where you can download any model and without any settings, and it should run if you have enough VRAM. I'll show you the enhancements we've made to the VRAM calculator. The only thing that I can't do for you is the best settings for the sampling parameters, like temperature and top P and top K, because that's not in the GGUF data.
Yeah.
So if the defaults that we have, which are rational defaults, don't work, then you need a model config. So I've ripped out the catalog system. There's no more catalog repo because you don't need it anymore.
Yeah, it's just anything.
That being said, you do have a catalog. It's now a personal catalog. So any model you download, I'll show you this, goes into your personal catalog file.
Okay.
And now if you upgrade to this version of Cronk, it will look at whatever models you have on disk and build out your personal catalog system. So there is a catalog, but it's now very personal based on what you're doing as opposed to, and that was a big milestone because again, things have to work out of the box. So I think on these aspects, we're better than Olama because Olama still has to have a Go template and they have to do a bunch of things. And then we've built plugin systems for parsing and we've built, I'll show you all that. But now, the also thing we did is we took a 30 millisecond hit, but not millisecond, sorry, microsecond hit. Actually, it might be milliseconds. Took a 30 millisecond hit to allow us to have IMC by default on any slot that you have. So you're not attached to a single slot anymore. So as requests come in, if you have 4 slots, we can run 4 requests in parallel. Your cache, if we match it, will go along with it. Massive performance improvements there. And now if you want to write that to disk, you can too, which is crazy. Anyway, there's a lot of shit there that I want to show you. So, but this is a great version of software for the model server now, which is technically now a production level model server because if you have enough memory and enough slots and enough GPU, this thing will run really well. But what's even better is the fact that we're really pushing SDK support to build your own stuff, which will never be as complicated as a model server. So feeling pretty good that if you are writing targeted apps for a model or two, this thing's going to be really robust. But let's take it for a test. Damn, nobody's heard me this whole time, bro.
I just saw the notification pop up when you.
Damn, dude. I just wasted all that time and nobody's online.
Oh,
so
no, they could hear us.
saw it.
A lot of them did. No, they could hear us. It was just it muted with whatever keybind you just hit.
Oh, you think
to
I
switch
just
tab.
did it?
Yeah.
Okay.
That's why, because I was looking and it was.
Oh, yeah, we never really adjusted the mic either. Okay, so everybody heard me.
Yeah.
Okay.
Yeah.
Thank God, dude, because that was like,
No, that was great.
no, I was gonna cry, man. That happens.
Yeah, we're good now.
Okay, everybody heard. Okay, so let me show you how powerful this system's become. And the thing I want to stress again is that you can build these things yourself. You can actually build your own model server if you wanted to, but it's all sort of baked into the SDK now, which is, I think, pretty powerful stuff. So let me show you this to sort of start here. I'm going to start the Cronk model server here. I always use the build just to make sure the UI is up to date. And now that we've got over 500 stars, the next plan is to get this in Homebrew now, so people can install it and just work off the CLI, which would start the server, obviously.
That would be cool.
So, oh, sorry, 11.435. Come on, localhost 11.435. Okay, so a couple things that you might see interesting and different here. So, lib management. Now, we identify the architecture that you're running on, right? And we pull down the libs for that. And so you can kind of see here that we've created this concept of a bundle now. So this is the default bundle because I'm running on an M5, right? That's my default bundle. But what we also now let you do is download any bundle you want. Because you might be running on Linux, but you might have 2 different cards that have two different sort of processors, and you want to be able to test one, say, bundle versus another.
Oh,
And
okay.
so
I
we'll
see.
let you now on disk have all the different, and so we've changed that too from a disk perspective. If I go to Cronk here. Now on disk, when we store the libraries, we do it at an OS architecture processor level. So you can have multiple bundles now on disk, and then there's an environment variable, cronk libpath, that you can change to run with the different bundle. So for me on an M5, not going to be a big deal, but for somebody like Florin, who has multiple cards on his machine and he wants to try different bundles, like he might want to use Vulkan. He might be like Linux, AMD, but he wants to try both CUDA and Vulkan, let's say, because he has an AMD card, but he's also got an NVIDIA card, and he wants to, like, he can do that. And then he'll manually just set the cronk libpath. And we also, for classroom activity, now allow us to be able to download these bundles peer-to-peer. Because in the classroom, the networks are pretty beat up.
Gotcha.
So this is a really exciting change that we made. And we'll be able to manage that.
That's pretty cool.
And another change I made for stability for people to win is, we've always like had the idea of updating this on the fly.
Mm-hmm.
Well, in the last month, they've made changes that have broke us until we could go back and fix it. Like they change APIs and stuff. So now in the lib package, I hard code a well-known working version. So every time I push code into main, I update this value. This is like the latest from today. So 124.4 is set to this. Now you can always say allow upgrade, which is what I do when I'm running the server. I use an environment variable when I run my make command to start the server. If I can find it here. So I'm always running latest when I run the server. But if I'm running the examples, then I'll use the latest, whatever's there. But for people just starting out, I know that I'm guaranteed they're going to have a good experience because we've locked into this, right? And they won't upgrade auto magically. So that's sort of been a problem. And this now I have to manually do this, but I'm updating the system all the time at this point. So I don't think it's been. So that's kind of cool, right? Like we've done that. Now in the models, this really hasn't changed, right? I mean, I'm going to be playing with the Qwen 3.6 model here, and you still get all the details, the model config information, the default sort of sampling parameters we're going to use, the template that's out of the GGUF. The new package we wrote, the Ginger package, worked so well that we're accurately sort of processing these templates now. And then you've got your VRAM calculator, which we've basically overhauled now to really give you a good idea of how much memory you need essentially to run this based on. Now, when I run this, I'm going to run this with 128 with 2 slots. We're going to keep that cache type there. So I need about 40 meg, but I'm going to show you some other sort of cool stuff here that we've done here. So this is all the models that are loaded on disk that you're able to manage. Refresh, rebuild, indexing, and all that sort of stuff. You could still pull any model. We've also changed the way we deal with model IDs now. We do auto discovery of things now. We can auto discover the models on Hugging Face. So if you give us this form, so the owner of the model and that sort of family, then we can discover that model for you, the Q80, right? And find the actual URLs, download it, and then update your personal catalog file.
Nice.
You can even do this, right? But when you do this, like whose version do you use?
Yeah.
So in the models, not in the models, in the by default, let me do this here. We'll switch this to Cronk. So in your Cronk folder now, you'll see a catalog folder, which is your personal catalog file. The GGUF cache is when we're extracting all that metadata, so we don't cache it so it's fast, right? But now in the catalog, there is this list of providers. I don't give you a way to edit this right now in the UI.
Okay.
But this is the order that we look for things in if you don't give us the provider, essentially.
Gotcha. Okay.
Right? So we'll always go after Onslaught first, then we'll go after the Llama CPP, then Bartowski, and then like sort of this order. If we don't find the model, then we don't find it. And you can always personally add to this. We'll write this out. We have in the defaults a version of this. And so we can, if we get some new family of, this is like the default catalog you get, just with even some models that I know that are good. So on a brand new system, this is sort of where you start.
Yeah.
And on a brand new system, this is sort of where you start. But you know, you can always edit that list. And so what's nice about that is you can do something like this, and if Onslaught has a model, so we do a lot of like web discovery now for this. You don't have to worry about knowing the full URL to the model. You can even specify a specific quant if that's sort of what you want to do.
Oh, wow. Okay.
So, but all the examples and everything we do now sort of work off of this sort of ID, and that's kind of cool. Now, if I open up OpenCode for just a bit, and I just say hello model, I'm going to be the Qwen36 model here. So hello model. Now, we're going to be loading this model up in memory, right? This model's already on disk. There's a lot of work that we've done to identify what the best configuration is for this model. We still have the concept of a model config, which honestly I only use now for my agents because I want a larger context window and I want to control the number of slots. And we know that these are the best sampling parameters. But for regular stuff, non-agent stuff, the defaults are going to be absolutely fine now.
Gotcha.
But here's the cool part. From the KMS point of view, the model server point of view now, look at all the information you get about the model that's currently loaded in memory related to the model server. We've come up with this concept of you can list the maximum number of models you want to load. We've always done that. But now what we do is we set that number high to maybe like 10 default.
Okay.
And then we have a new number called a resource budget. I've set it to 80%. Essentially, you can load as many models as you want in memory as long as you're under 80% of the total physical memory on the machine. So
Gotcha.
and we did that because if you set that number to 2, there could be a lot of memory left to run another model, and you're not doing that. You're evicting it. In this case now, if I were to go and switch to now wanting to run the Gamma 4 model, and I say hello model, boom. So now I've got the 2 models in memory, right? I'm only using 73% of the memory that I'm willing to allow on the budget, right? So I'm using 73% of my budget here on these 2 models. All right, I still have all this. So now if I wanted to do this again, let's use the chat app for this, right? So let's say I'm gonna play with the Qwen38B, right? Hello model. Now we're loading another model into memory. Boom.
Okay.
See,
yeah.
now before we wouldn't have done that. We would have evicted something, but there's still, right?
You still have
They
budget.
still have budget left.
Yep.
And so we're able to load that model up. I could come back here now and go even smaller. Like this is an even smaller model, right? So the default is like 10 models. But with the budget, I now have 4 models in memory. It's comfortable, right?
Yeah, as long as it fits on the machine.
As long as it fits within the scope of your resource. But I mean, you could say 100%, but this is unified memory. Like, you still need some memory for your operating system and stuff to work, right?
So what happens when you go over budget?
So then a model has to be evicted. So
Okay.
let's say that we do that right now, right? I go with the, whoa. That thing just went off the deep end. Whoa, man. Wow, you just went off the deep end on reasoning. Wow, I've never seen that before.
It just
Anyway,
started,
it's not good. All right, let's say I went with the non-agent version, right? Or the Omni is a big model, okay? Actually, This is a great test. This is a big model here, okay? So now we're going to go over budget, and we're going to have to evict. So it looks like it evicted the Gemma 4 model,
Okay.
okay? And now we stay in budget.
So is it like a random?
It's doing it based on it being able to fit that model in memory. So the Gemma 4 probably was a little bigger. So it will look at that, and then we'll look at the last model, like how long it's been since it was used. Because if it's being used, you don't want to necessarily evict it. But how cool is that, right?
Yeah.
We've allowed that to go in. And then obviously we can come in here and unload models too from memory manually. And
Very cool.
and then we're flying high here. So all of this work has been done, and it's this work here that's given us more flexibility in leveraging the memory that you have. Now, why that other model went off the deep end, we're gonna have to look at some point. So we've done this work too, which is all tied into, again, you not having to worry about anything.
Yeah, that's
And
nice.
then this is from your catalog file.
Oh, this is different now too.
Yeah, I made it smaller, so we went there. But so you still have the same sort of filter capabilities here, and you can still, like this one is in the catalog for some reason, but we haven't downloaded it. I must have had this on disk or something. So like, I want to get rid of that. I should have a delete here for
Remove model.
remove model.
Yep.
Yeah, better. Okay, so cool, right? And then you can also come into your catalog and download the things that are not downloaded. And again, look at the model card, the catalog information that we've added, the VRAM calculator stuff again. You can even pull it if you have to. So we've done this is really cool stuff that we've sort of done here now. And for your ability to manage this sort of entire system. But I think the personal catalog file was a great way to go, because now you can just come in here, download any model you want that you find, right? Just give me this.
It's just a lot more dynamic now.
And we download the projection file for you. You don't have to worry about, is there a projection file? We will, by default, use the F16 version of the projection file. So that problem goes away too. If you're looking at a media model, all that sort of goes away. All right, so let me come back to running, because I'm on the Gemma. I'm going to switch back to the Qwen 3.6 and the Gemma 4 are working pretty much identical.
Okay.
But let's just keep the Qwen 6 in memory there. Okay, nice.
I love the UI too. Like, it's perfect.
Yeah, no, it's really badass, isn't it?
I like this screen a lot.
Yeah, it's giving you real insight. Now, if you're running on the SDK, you're not going to have this. I mean, if you're using the new pool package, which we wrote, to load and unload models, then you get this information, like not through the browser, but there's APIs for this. So what we did in the project was expose a new package under the SDK called Pool. And that's the resource manager that you're seeing all that information in. And so you could have all these examples use the SDK directly. But if you wanted all of that sort of support, you would then create a new pool. And then you would essentially acquire the model with that ID. And if it's already on disk, then it will load that up and manage that for you, and you get back a Cronk SDK API, right? So essentially, here's an acquire. So acquire that model. Now you have an API, and everything else is the same after that. And then you don't have to worry about really releasing it, because if you don't use it, whatever the settings are, the time to live setting, then it will automatically just evict it anyway, right?
Okay.
So you don't have to worry about. So here, can't be more the time to live, whatever we did there. Whatever it was, I have to look at this example. Actually, that's 15 seconds.
15
It's
seconds,
kind of
yeah.
silly, right? That's kind of too short. But basically, if you don't use it in 15 seconds, we'll evict it,
Okay.
right? And so that's how you sort of think of it. So you acquire, but you don't have to necessarily release it anymore, because once you've acquired it, we load it up in memory, and then these sort of things, the budget percentages and this stuff takes over. So this is another option now for people who don't want to. They might be using multiple models. They don't want to necessarily manage it. They've got memory stuff. Because if you just use the API directly, then the model stays in memory until you release it'll release the API or the
Yeah.
SDK, right? You call it unload or something. So it's just another option for people who want the extra memory management. But all the other examples that we have here will just have you go right to managing it yourself, right? With a new Cronk. So, but I figured since we did all this pooling for the model server, we might as well expose the API along with everything else for everybody. So you now have that as part of the SDK.
Very cool.
Okay, so I've got a model server running. Let me just say hello model again. By default now IMC is on.
Okay.
So you don't have to worry about turning that on and off, because we don't attach it directly to a slot anymore. You get an open slot. If the next message comes in and we can identify that it is part of an existing session, then we get attached to it. So the performance now is like really crazy. But one of the things I learned in Bruno is that the template is, the model has been trained in a very specific way, with very specific markers being issued in a very particular way.
Okay.
And so if you give the model input exactly the way, 100% exactly the way it's been trained, it will 100% behave properly. But any slight deviation on input, it will appear to behave, and sometimes it will behave 100%, but over time, it will not behave properly. And so you think that everything's working until it doesn't.
Okay.
And that's what I've been experiencing for 2 months.
Huh.
So when we wrote the new Jinja template, and I removed some hacks that we had in there, like adding the name to the tool call.
Yep.
And the most important thing that we found, when we make a tool call, we send JSON back to the open code, right? That's how it works. We send JSON with the command and the parameters.
Yep.
So open code on the next message sends everything back, including the tool call. Well, it's sending us back the tool call in the same JSON format. Makes sense, because that's what it has, right?
Yeah.
We gave it to it in a certain format with JSON. It sent it back in the same format with JSON and then the results.
Okay.
Well, we learned that the template, right, the model didn't train on tool calling in JSON. It did as a response, but not as an input. When we studied the template, we realized that the tool call itself that the model made had to be fed back into the model in the same sort of structure that it spit it out in. So let me say it this way. The model gave us a tool call in a particular structure. The chat completions API says, well, you need to send it to the client in JSON. because chat completions protocol says this is the format for a tool call. The model gave it to you in structure A. We have to convert it to JSON, give it back to the client. Now, when the client sends it back the way we sent it. Now, we were giving the model back the tool call, not in its own structure, but in the chat completions structure. Now, the model, 90% of the time, handled that fine. But that 10% of the time that it was spitting out bad JSON and bad missing parameters and all that, it was due to that. It was due to us not putting that JSON back into its own sort of structure.
Yeah.
When we did that, everything worked so well that we don't even run, we're running Q4 KM models now. We're not running Q8 extra large. Now, why are we doing this? Where did we come up with this one, right? Because we were always running Q8 KXL, right? Which is always like another 10 gig larger because we thought it'd be more accurate.
Exactly.
Florin and I noticed in Bruno, because what I was doing was running these models in Olama locally and running it through Cronk. And Olama was kicking ass, and we were not. Olama didn't have any problem with tool calls back and forth. We were at some point. I wrote a whole JSON repair package because the model was spitting out bad JSON. It was because we weren't feeding the template properly, but nonetheless, it was doing that. Even these small models still might do that. But Olama was only using the Q4 KM models for everything, which was even more mind-blowing because they were running Q4 level models more accurately than we could run the Q8.
Yeah.
I was banging my head against the table. And so with AMP, we kept trying to study what was Olama doing, what was Olama doing that we weren't. Now, they do a lot of different things with Go templating and stuff. But that's when we discovered we were not feeding the model template properly with the tool calls. Not the response, but the tool call itself that it gave us originally. We had to feed that back in. Now, I didn't have to put the name back in to anything because the template was processing it and giving it back to the model the way it was trained. In fact, injecting the name was causing all sorts of problems, not with Quen, but with Gemma 4. I ripped that out. Then I started playing with the GPT model again, and it was working perfectly without that hack. So I've learned something. The template is critical to the stability of the model. And if you're not producing the exact sort of training tokens, right, structure, the model's always going to, at some level, misbehave, sometimes slightly. So it feels like it's working, and sometimes. So now, if I don't have a model behaving 100% accurately anymore, I know that there's something with the template or us using the template incorrectly. But our new Ginger package is so good that because Ganja was changing it and not changing it for the better, right?
Okay.
It was now slightly changing again how we were inputting stuff into the model. So the Q4 KM is like badass because now we're doing everything perfectly for both Gemma 4 and Quen 3.6.
That's cool. That's interesting.
I know, dude. This was months of us trying to figure out, like, what are we doing wrong? And I had bugs in the IMC because I was trying to do things way too complicated. So complexity is death. So I simplified all of the caching. Essentially now, if we don't find a match, because what was happening was, I always thought at some level maybe the templates were non-deterministic. And they can be. But open code is non-deterministic. As that context window grows, it does things different. And so now what we do is when messages come in, we take the hash, we look at it, we match it. If even anything is off, then all we try to do is we check the system prompt. We separate the system prompt from the messaging.
Okay.
If anything's changed in the messaging, but the system prompt is the same, we keep the tokens for the system prompt. but then we just process everything again. Now, that might take 2 seconds, but it's accurate.
Yeah.
And there's nothing we can do about it. Somebody's changed something. But we are still able to identify that this is your session.
Mm-hmm.
But what I was trying to do before was figure out, well, what changed? Just cut that out and start from there. No, bugs, nasty bugs. Because different templates and different model architectures. So what I learned was the hybrid model architecture injects essentially hidden characters into the messaging at the template level. So you can't clean that up because there's these hidden characters in there that you don't know, and the hybrid models were a complete and utter mess.
So what does stay consistent is the system prompt and user messaging.
Potentially, but even that, the template could, for a new message after a long list, it could produce something different. The system prompt tends to be exactly the same for every new session.
Gotcha.
But over time, the messages could produce a different output when it runs through the template. And so now when that happens, I don't try to be cute. I don't try to be fancy. I just throw it out. If it takes 2 seconds, it takes 2 seconds. But the quality is there 100%.
Which is what's more important anyway.
It's always more, integrity is always more important. So we're doing those sorts of things now too.
Interesting.
So watch this. So as a simple start here, how can I help you today? Okay, so I'm going to go into my talks folder here under examples.
Let's do this for a few minutes.
Yeah. And I've got a silly little prompt that I wrote here that will write a tic-tac-toe game. So write a simple tic-tac-toe game. Don't overthink it. In the terminal, put it here, okay? Print the board exactly like this. I give it rules on how to play. I even tell it to use colors for X and O and all that. And, don't just write this and I'll deal with the rest of it, okay? So I'm gonna take this. Anybody on the code base can sort of see this. I tell it to compile the program to validate it, compile it, okay? And so we do all this. All right, so this is Q4. I still use the UDs, I like them. Q4KM 36 model. I'm gonna tell it to write this game. A month ago, this would not have worked, especially with the Q4 model.
It's crazy. I feel like this is the most big changes I've seen so far with Kronk. Like,
These massive improvement changes. Yeah.
I think so.
And stability.
It's just a lot more dynamic. It seems like it's a lot less user sort of error that can happen.
It had to be, because if not, nobody can use it. Who's an expert in all these things?
Yeah.
It's just a bummer that the sampling parameters aren't in the GGUF data, because then
you can really dial it in for each model. Yeah.
Like, because Onslaught could put it in there, and if we see it, then we could use it, but it's not
exactly. So you still have that work to do.
Okay, it just wrote no problems, no tool call issues, nothing, right? Just wrote that. So and it wrote the tic-tac-toe folder. There it is. Okay, so let's see how well I did on this first round here. Okay, so it didn't do everything. Like, these lines should have been green, so we'll have it refactor it. And a lot of times, the models were working really good on the first prompt, and then failing miserably on refactoring. And it was because the tool call stuff that we were doing was wrong. But let's just see something here. Okay, so it's not working at all, right?
Yep.
That's fine. So let's just tell it. Okay, so game not working. So I am selecting a number, and the X and O pieces are not showing on the board. Also, the vertical lines on the board are in white, not green. Okay, so it wrote some code. It didn't write a game that worked, but let's see what happens here. This had never worked until we fixed the two calling structures back into the templates, and we were doing templating better. But everybody gets this stuff for free now.
Yeah. It's crazy. And this is completely local too. On a
Yeah, it's the MOE model. It would be better if we could run the dense models because every layer runs through. It's just too slow on this machine to run the dense model.
Gotcha.
These MOE models, because you're only activating like 4 layers at a time, they give you this better performance. And as long as the accuracy is good enough, I mean, who cares for this sort of stuff? But now that I've got those other big machines in there, I want to run these same models, but in these sort of dense. So this is taking way too long, right? I can do this sometimes, and it just works beautifully out of the box. And for me, it's overthinking now. A lot of times I got to tell this model with each, that's weird. Yeah, okay, that's good. I don't think it was clearing the screen right. Anyway,
Interesting.
so this sucks, right? It's now maybe I broke something because with some of the new refactoring that we were doing, right? Because it's overthinking this. So let's see what it does now.
It's rewriting.
See how it's, wait,
Yeah, it's like going in circles.
right, it's going in circles. So, and that's a bummer. Like I haven't seen it sort of go in circles like this for a wee bit. But once this is done, it will accept my stop. Worst case, I have to just hit escape. So let's do this. Okay. You're overthinking this. Just fix the bugs I provided.
Okay, so we see an actual change there.
All right.
Okay.
That's it. Good.
Okay.
Good. 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 Okay. Cool, right?
There
All
we
right,
go.
so let's do the following now. New. Let's switch to the Gamma 4 model. I'm going to delete that. And we'll see what the Gamma... So you see how the Quen 3.5 went? Just overthinks
Yeah.
all the time. Every time I feed it the next thing, I have to tell it, don't overthink, don't overthink.
Yeah.
Don't overthink.
Keep it simple. Yeah.
Don't like it's very good at the first prompt, and then it just wants to sort of overthink everything.
Mm-hmm.
But there are times where it doesn't. There are times. And remember, this is the Q4 KM.
Yeah.
But there are times where it doesn't. It just like so. Let's see what the Gamma 4 model does. We'll give it the same prompt. Shoot. Hit the wrong button.
Lines. Okay. This is cool though. Just seeing it actually doing this.
just that being able to do this with the Q4 medium-sized models is really interesting. If it wasn't for the fact that Olama, Florin and I were both shocked that Olama is always using the Q4 KMs. Always.
That's interesting.
Now, I made a lot of changes in the last week, and I have all my testing and stuff, but accuracy testing is really, really hard to sort of pull off, you know?
Yeah.
It isn't until I do these types of things do I get a sense of how we did. So I think there is. It hasn't written anything out yet. This might be the final code it wants to write.
And is this one the larger model?
These are just the same.
Or they're the same?
It's just
Okay.
the Quen 3.6 versus the Gemma 4. Quen 3.6 comes out of China, Gemma 4 came out of Google.
Gotcha.
This model is a little larger, I think. We can see what the size is actually.
Quen 3.
So the Quen
is
is
bigger.
larger by about 5 gig.
Yep.
I almost feel like some of these latest changes I made are bad because I felt like earlier in the week this was moving much faster, but
Write this file. It's not using much context.
well, you're not seeing it until it comes back, right? Because you're
okay.
just seeing the model spit out, so we don't have a new context number yet.
So it hasn't updated it yet. Okay. Yeah.
Okay, we have a main.go. I don't know if it works already. So, didn't really paint the board perfectly well there, right?
No.
Okay, so let's give this to it. So, you did not paint the board properly based on instructions. This is what I am seeing. Let's see how well it does on the refactoring. Now, it got there for the small model, right? Like,
Yep.
and this is the most complex stuff that you can be asking these models to do. So,
Yep. It's a solid top because it has to know where to place things and sort of it has like a visual aspect to it.
but there are times I ask it to do this, and it just like,
It just spits it out.
yeah, it's beautiful. But the fact that none of the tool calling is failing, even though it's, I think, overthinking. I hate when I see wait.
Yeah. The weight, this, that.
But this time that was good. Wait. Okay, I will update the render board.
Remove some code there.
Okay. But no tool call failing, no,
No.
you're just cranking it out, right?
Is spamming my email.
So anybody watching this, you can do these things in your own app now, right? You're just leveraging the SDK. You can take any model size and start building apps that can leverage these models on tool calling and tell it to do, right? Let the model decide. So I'm starting it early here.
Okay. It
So-
did fix it.
It's fixed it right out of the box. It doesn't know it. And that's what I've seen with the Gemma model is it's fixed it and then it's like, wait, right?
Yeah, like it already.
right? And I would just say, hey, stop, you fixed it. And I don't know why these models sort of second guess themselves. But pretty cool, right? Like
Yeah.
this one did it pretty much out of the box with one mistake on that. But again, it's sort of overthinking this. Now, I don't know if this overthinking is because I added a bug in the last sort of week, but you see how it's just
like not. Yeah, it's like.
it doesn't trust itself, right?
We should make sure I didn't leave any. There's a lot of weight.
So I'm always having to like, okay, right, stop, you fixed it. Now, if I started that with don't overthink this, just do what you think you need to do, it will work much better. And that's just, and I have it in my system prompts, right? Like, okay, so you saw that, right? Both of them sort of wrote this code. One would argue that Gemma 4 did it a little bit better. So I'm going to go back to that in a second. But I'm trying to find. I should just go on disk and look for this. No, that's not the one I want. That was today. Ah, here.
Oh, okay. There.
Let me save that in a file here. Okay, so here's a prompt to create an asteroids game. I'm not going to read it. The only thing I have to remember is where I asked it to put it, but
Put the game under the examples folder.
is that what I did?
I saw it in the last couple lines. Yeah, there.
Okay, cool.
So is this kind of how you test like accuracy, or
This is how I've been, after all the tests pass and all that, this is how I've been testing the model's behavior a little bit. And I feel like before I split out before I added the KV cache, making it composable to RAM or storage and some other things, I feel like it was behaving a little bit better. But none of that code really changed. So none of that should have been affected. I didn't necessarily change the way, the core code to save KV cache and bring it back. But that being said, I feel like it does better with TypeScript as well. It does better with JavaScript. Now, I told this prompt to use, to do it in Go and HTMX.
Okay. Yep.
Essentially. But only use that to deliver the code to the browser. Still do the game and everything in HTML, CSS, and JavaScript, right?
Got it.
But we just that way I didn't have to start Node.
Exactly. Yeah. No frameworks.
Okay. So I told it to put it under here. So it's doing this, right?
And this is a much more complicated task.
You would think, but I feel like these models are better at the web shit than in Go. But how cool is this on a Q4KM model?
Yeah. I mean, it seems like it's working better on this sort of task.
Yeah. But I still have to make sure every time I reprompt it to say, hey, don't overthink.
Mm-hmm.
Just trust your, first implementation.
It's writing the main logic now.
I just like it took me before we would have had tool call problem.
Yep.
And I don't know, I haven't looked since we made that one tool call fix to the template if the JSON repair package is actually doing anything anymore. But every time we have JSON for a tool call, we run it through the unmarshaller. If it fails, we try to repair it
Oh, okay.
blindly at some level and then feed it
Got
back.
it.
So I should put in there just to see if we're actually repairing anything. It'd be interesting. I have a feeling that when we fixed the tool calling stuff, the model stopped spitting out bad. But the Gamma 4 will use, instead of quotes, less than pipe quote. It will do that because it's using that
Okay.
as like quote markers sometimes. So it can have other quotes on the inside.
Oh,
You know, because
okay.
you can't have quote, usually.
It'll like
you need
escape it.
right, but instead of escaping it, it sort of does it like this.
Oh.
And then it can have something with quotes in it here, right?
Mm-hmm.
And so we still have to deal with that anyway. JSON Repair knows how to handle that situation,
Gotcha.
which will come out of Gamma 4.
Seems like it's still just. Oh, there it is.
Yeah, 800 lines of code.
That's a big.
Ba-boom. But think about how complex that is in JSON coming back out that we're now parsing, right? Okay, let's see. I asked it to add its own module files too, I think. Yep.
Come on. Okay.
Okay, I think we have our first version.
Static check.
Go run main.go. See, now it's going to try to run it.
Yeah.
It shouldn't try to run it.
Game running at. Enter. Oh, I let you click.
Let's see.
Done.
Okay, we're running on localhost 8000. Let's see what happens.
I'm curious how this looks.
I said 8000?
8080.
880.
What?
Asteroid, start game.
Oh.
Ah.
Oh, that's cool. No way, with little like effects and everything.
I feel like the arrow keys are fucked up. But
Like it's overspinning.
no, like I want it to go left and I don't know. But I'm not a gamer, bro.
That is cool though. One shot. What?
Pretty good, right?
That is pretty good. That's pretty good.
See, it's better at the TypeScript than the Go there. And that was
Yeah.
Gamma 4, right? So, all right, so watch this.
That's a cool one.
All right. That was Gamma 4, right? Oh, no, that was Quen 3.6.
That was fun.
Okay, that was Quen 3.6.
Yeah, I was gonna say it would hurt to delete that.
No, we've done this. Go on. Hello, model. Okay. Let's see how Gamma 4. So that was beautiful.
Yeah, that was perfect.
Right? Like perfect, right? That's what I'm excited. Like Kronk is finally at a place where you could really use it for production level stuff. like model server is a generalized sort of problem, and I don't expect people to be doing generalized problems with this. You'll have a very specific problem you want to sort of solve.
Mm-hmm.
But this model server is ready to go too if you wanted to use it, say over Olama or something else.
Yeah.
And I think we're better because Olama always gets early access to the models because they have to do all this work to prepare for it.
Yeah.
We could take that model right off of Hugging Face now.
It's dynamic.
Now,
so
if it's a brand new model we've never seen before with a different parsing, with a different sort of template language, we'd have to add a parser. But,
Okay.
but it doesn't break any of the existing parsing code, right? So that's where these parsers under cron parsers come in. So these know how
okay.
to parse the output coming out of the model for both the tool calling, like that's like what we're looking for in terms of tool calls,
Okay.
and then the state machine for also handling what's coming out of here for even thinking and stuff. But we've made this now, there's an interface there now for this, right? And what we also do when the model loads up, so when you load that model for the first time,
Mm-hmm.
we run through this sort of code here in the parsers to figure out which model you have.
Oh.
So we have this thing called, must be new here. We're able to identify which model you are, so we don't have to try to find everything. So if we identify you're the gamma model, now we're more efficient because then we know that this is all we should be looking for.
Got it.
You see
Okay.
what I'm saying?
Yeah.
As opposed to before, everything was one big blob and you were just looking for everything, which would have made things easily breakable later on.
Yep.
Now, what we do is we have a list of, on startup, we have this list here of parsers. And then this is the order that we go through to try to identify when you load the model. We'll look at the template first, see if we're finding certain markers out of the template, like this. If we don't find anything, then we look for the name. See this name
Yep.
in the model as a backup. And then in a very worst case scenario, we just use this standard one, which probably won't work. And then we just have to come in here and add a new parser for that new model. And it might be like Gemma 5 is different or something.
Yeah.
So we're trying to
Interesting.
do that for you too. So you have to think about this. You can always, I don't even let you override this because I didn't want this to even be a setting.
Mm.
Oh,
Oh, it's done.
it finished much faster, didn't it?
That was much faster. And this one's the smaller model.
Yeah,
Gamma 4.
this is the Gemma 4. Okay, we're in asteroids. Ready? Man, it did this much faster, didn't it? Florin loves that Quen 3, but I don't know, man. The Gemma 4 has been, it's always feeling faster to me. I might switch that back over as my, now this game don't look as good.
It does not look as good.
No, it doesn't look as good. That,
With the
that,
little
that Quen
triangle.
3 was,
The Quen 3 did. That was like a legit. It had a home screen and everything.
yeah. Yeah, it did a much better job, didn't it? But still,
It looks like
it did this one faster.
it did. I think it just didn't do as much, too. With the effects and styling.
Anyway, pretty wild, isn't it?
It is pretty cool, though.
All right. So, get rid of this. So, you're now seeing all these improvements that we've made in the level. But now I want to do the following again. I'm going to go back to the Quen model. And hello model, just to make sure it's loaded up again. Let's go back and have it do the tic-tac-toe one more time. Okay, let's have it do the tic-tac-toe one more time.
It would be cool to see it do the tic-tac-toe in a similar, like, HTML, CSS, like, web way.
It would, but what I want to do is show you how we can integrate the Cronk SDK now to be, now this is bad.
Yeah, I saw that.
So this has not happened in a very long time. So this is important here. We need to look at this. Hold on.
Received undefined.
Yeah, no, it's not good. I need, my guess is it was all of this. So I'm gonna have to look at this. Hold on.
Oh, there it is.
Yeah, but I gotta get to sort of the beginning of this. Something bad happened.
Oh, I saw directory just tool call.
Yeah, I'm
No.
looking for the beginning of this whole session. So this will be the beginning of it. All right, let me find here. Here, okay. Let's take all of this. This has not happened in a long time, bro, so this is not good. Okay, so we had a tool call issue, which we haven't seen in a long time. I need you to review the logs and tell me if this was a JSON repair problem or something else. Now, before I do that though, okay. Now we finished the game, but let's see what AMP sort of comes up with here. I haven't seen that in so long, but we've made changes, right? So
That's
so it didn't, it's not rendering the board right
No.
now. So, okay. Overthink this refactoring, this, I think this bug fix we need. You are not
model
rendering the
omitted
board
content.
properly. Screen should clear after every entry, every input. This is what you did. Okay, let's see here. This is not JSON repair, it's a model output defect, which sucks because I haven't seen that in a long time. I have not seen the model do this in a long time. Maybe we have some KB cache corruption in RAM, and you review all the IMC stuff from the logs and make sure we didn't do something wrong with extending or eviction. So these logs have been designed by the agent for our ability to read this stuff.
Mm-hmm.
So from my perspective, if this is happening, we may have, in these last changes, corrupted something by extracting the RAM facility out of the code, right?
Okay.
So I'm gonna have it review all the logs for that. So let's see what it does here. Again, it's sort of overthinking, isn't it? I think I may have corrupted. The only way to truly know this would be to go back into the commit history and do this again on like the previous version that I had and see if there's behavior. Because this is 124.4, right? See what happens in 124.3.
What's on the? Oh, because some of those features
Yeah,
or changes
maybe
are
I
already
broke
in.
something. Yeah.
They're already in main.
Let's see. It's amazing the model can do this.
Yeah, this is.
Which is good. I have 2 slots. This is what happens is on every new session, it sends 2 requests. One for this dumbass title, which I don't know why. It's amazing too that it can reason to extract that. I don't know how they make the models do this.
This is wild.
Okay.
Hmm.
Let's see now. Okay, so, okay. The board is rendering. It wrote an entire Asteroids game in TypeScript.
I know.
Right?
And now to do this simple.
Cleanly accept you are not clearing the screen before you render the board.
Board after a turn. Yeah.
Just crazy, right? It just built a complex Asteroids game, but
With animations and everything.
I can't, like, I've seen it behave better than this. But this is why the logs are the way they are, right? Like, we didn't do anything wrong here. Everything is clean. So the only thing I could do is switch down to like maybe 124.2 and run this.
And
if
compare
there's
it.
a behavior change, then I have to like say, look, the model's behaving 10 times better on this version than it is this. So
It's just interesting because You would have to run it more than once too to really know. Unless it's like a drastic difference. It's just interesting how I can write the whole Asteroids game, and then this is like TUI. It just doesn't.
I would have to go back to 124.2 because in 124.3 we added the composable KV. No, in 4 I just did the composable. We did the parsers in 3. Okay, let's see. Now it's working.
There it is.
Okay. Okay. What enhancements could we make to this game?
Okay. AI opponent.
We're going to do that manually. Score tracking. Okay. Add the score tracking. I want that to be rendered at the top of the screen, just above the board. Make sure there's a line space between the score and the bar. Okay, let's do this, and then I'll show you how we integrate really quickly the cronk. We'll do that manually so you can see it.
Update the score engine. Okay.
I played with the Q8 extra large too, and I didn't feel like it was behaving any better, to be honest with you, than the Q4 KM. Now we do keep a full 16-bit KV cache. I think you can't cut that down. I think you can cut the knobs down, but I don't think that what's being rendered output, I think if you start cutting that, it really digs into its reasoning ability. You know, the data it's producing. You want to keep that at full length. But, you know, we're knocking all the knobs down at the same sort of level, and it just sort of behaves at the same level.
Okay, I see.
But when it's being produced and reading and understanding like that, you don't want to cut that. So if you're going to cut your KV value, then you have to run at the highest level. You got to keep the knobs. You can't cut both. So either you cut the knobs like we're doing from basically F16 to Q4, and then you got to keep the full precision in the KV cache. Can't cut both.
Got it. Oh, it says done.
Let's see. I got a score. Nice. 1, 2, 3, 5, 4, 8. Yes, play again. Nice.
Cool.
Did that. Okay. So what we now have is a tic-tac-toe game. That one, much better with the one bug, but we recovered because we're able to do that, and we verified that we didn't have, we did everything we could. It's going to happen. Okay.
Yeah.
So we now have this program. What I want to do now is, let's fix some of this. Could use the tag switch. Here's the other thing about the models. They're like trained on an older version of Go. So like the Go fix stuff here, unused parameter, right? Like it passed in this, but it didn't use it. I don't think you can do a quick fix. Let's just get rid of it, right?
Yeah, it's unused.
And actually, we're gonna need this, actually. We're gonna need it for O. So let's leave it for O. We don't need it for X. Because what I want to do is I want player O to be the model.
Okay.
Okay, so let's see what is happening here in read move. So essentially read move is picking a number and, oh, it's right above it, and returning that number out, right?
Yep.
Okay, that's cool. So we won't be using read move here. We want the model to essentially pick a number from X, Y, Z. So this is actually a perfect sort of setup because I'm assuming that this string is a set of X, Y, and Z when they're rendering it, right?
That would make sense.
Yeah. So somewhere along the line, player 0 came out and X marker or, oh, if it's not already an X or Y, do that, else put the O marker in, right? So we get all that for free. So yes, there's going to be an O marker or an X marker that we can look at. Okay, so this is cool. So essentially what we need is, we need to know what the board looks like. We need a prompt. Well, first of all, we need an API to even talk to the model at all, right? So let's come up here for a second. Oh, here's another Go thing, like that's new in Go, right? So let's do this first. I like having my main function at the top. I always have. Like that should be the first function here, okay? And this function main basically doesn't really handle errors at all in here. That's fine. But we need to do some initialization, don't we? Even that I'd rather have a var, but we'll just keep this. So let's write, let's just write a function here for a second and I'll move it, right? Nick Kronk. And I know this is gonna have to return a star Kronk or an error. Or one of these two things are gonna happen. Now, how do we initialize a Kronk for use? Well, dude, I'm just gonna go to the question example because why would I have that 100% in my head? I know there's this install system that we have to deal with. Okay, so install system requires us to make sure that we have libraries loaded.
Yep.
I already know I've got libraries loaded, right? So I don't have to worry about downloading them. And then getting access to the model that we want to use. This one becomes important. So let me steal this code here. And really, I just need technically, I just need the physical location of the model, if I'm being really honest, right? So one could argue that maybe I just do this here. I know where the model is. The model is here on, let me see, on disk. It's right here. Models, on sloth. Like I could use the tools package to do this, but let's just say we're gonna do this model here, right? That's the model right there. I hate that I'm in this screen and I can never.
You can't get a path. Yes.
You can, but you have to like come in here
and do it. Yep.
and do it here, right?
There's not just like a copy path.
No.
That would be amazing.
I know. I don't know why it's not in here. Like I feel like I'm missing something.
Like a shortcut or.
Yeah, I just don't understand it, dude. Like I don't know why I can't just say path, right? Other than this is crazy. Anyway. That's the file, right? That's the model file. Model file. That's where it is on disk. So I could technically just do this without all the other shigamadig. Now, I have to call a init in order to load the libraries and everything that's there. Then I need a API. Now, the API needs the model file and it just needs the physical location of that, right? That's what the raw API needs. So I should be able to just do that, right? The models package and stuff makes that easier for you to, and if the model's not already downloaded and yada, 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 but this should be fine here. I could even log all this stuff, but I'm not going to do that. We'll just do this. And that's all I need, dude. I need a model on disk, and I need to call init, and then I have that. So what I could do now is just say init, maybe even just use a lowercase init cronk, and if we do krn and an error, and if error doesn't equal nil, yep, I could just do a dot print line error os exit 1, right?
Yep.
All right, so I can do that. Okay, now I got an API that needs to be passed to player 0, because that's who we're going to be using. There it is.
Yep.
Plus the board. So what if we do that? Then I go to player 0 and we say you are a cronk.
Uppercase.
Capital K would help. Now we've got everything we need to sort of do this. Okay, so ideally, the idea is that we're going to make a call to the model. We're going to ask it to pick a box that's available. So it
Yep.
has to know what's available.
Yep.
And then we're going to take that and return it instead of the move. Now, I could sit here and play with this prompt, but just for time, for a second, I kind of developed 2 prompts already that I know sort of work. I have this system prompt. And we could use this system prompt that says direct answer only, include the absolute minimum reasoning. In fact, we don't even need reasoning. We can even turn the reasoning off, technically, right? So I think if I think about this, even for the talk that I'm doing, right? We're going to turn the reasoning off. We don't need it. I just need a answer to this problem, right? So I want you to return this JSON and only return the JSON as your answer. Don't send me anything else. So system prompt, right? Okay. Then this is sort of like the game prompt.
Okay.
Right? Maybe we call it game prompt, right? It'd be a better name for it. Okay, so here's the game prompt. You're playing a game of tic-tac-toe. You need to pick a space from 1 through 9. This is what the board looks like. You can see how that you are player 2, you're the 0. And then there's data that we're going to feed in here, okay?
Okay.
All the spaces, X for player 1, your spaces and what's available. And then choose a place and then return that JSON document. That's it. So we just need this sort of data, right? And we have a game prompt.
Yeah.
So let's do the data first, right? I need to know all the X player positions, which would be some slice of numbers, actually. I need to know, is it 1, 2, 3, 4, 5, 6, or something like that?
Oh, okay.
Right.
It's not yeah.
I need the Y player positions. Sorry. And then I need the available positions. Now, we could just say, fine, for, there's 9. Okay, so for I, range over B. Now, if we could do sort of a switch here, right? Switch B sub I. Case that's an X, and we had some constants here, didn't we? X marker, right?
Yep.
Case that's an X marker, then what do we know?
What's
We
that
know
X?
that X player equals append X player I plus 1 because that's going to be 0. And we need it in that case. O marker, we need an O player. And if it's none of those, then available gets I plus 1. So there's our data, right? And now what we need to do is essentially say prompt equals, let me do it this way, func dot sprintf, and we'll take our game prompt. It already has the markers in there. And we should be able to just say X player, O player, and available. And that should already put it in like a square for us with those values. So we'll validate that in a second, but that would be our prompt, right?
Okay.
Actually, we can even test that right now just by doing the following. We could do a func print line, just dump some,
Yeah.
dump prompt out. And then I'm just going to do like an OS exit here. So it doesn't do anything.
Yeah.
I can't type anymore, bro. All right. Let's just run the program like this. And we should at least see a prompt that has the fill in the blanks, right?
Yeah.
Oh, let's try it.
Oh.
And it's got to load the model. So we
Yep.
know that's working.
It is loading model.
Okay, so we know the load the model works. So we do 1, and then we got this prompt. So you're playing a tic-tac-toe game. Player 1 is at 1. You're not occupying any spaces. And see how cool that was?
Yeah.
We got, that's perfect, right? Like that's exactly what we
2,
needed.
3, 4, 7, 8. Okay. Yeah.
Okay, so we have this. Yay. Now, we have to run this prompt through the model to make anything work, right? So what we could do is the following. Just to show you how easy this can be. Okay, so the next step is essentially to set up, I don't want to use streaming, I want to use non-streaming. So this is the next step, okay. We now have to make this call. So what we're going to do is create a model D. This is going to be the input into the API. We're going to have the system prompt and our final prompt. That will be role system, that will be a role user. We're going to disable thinking because we don't need it thinking to make a decision. Just give me a decision with the temperature top P and top K that we know is valid for this model. Now, the next step is we make a chat call. Now, we need a context that has some time on it. So let's just do that. Context dot with timeout. Context dot background. And whatever, we'll give it like 30 seconds, right? Okay. And oh, it has a cancel function. Gotta defer the cancel. Perfect. And now we've got context. Now, this could fail, in which case we need to return an error. But just because of where we are right now, and I don't want to deal with it, if it fails, I'm just going to do this, which is bad, but I'm just going to do that.
Yep.
Now, we get back a model response at that point, okay? Which essentially the content should be right here. So that's going to be a string with the JSON that came back, essentially, right?
Okay.
That's the JSON. So if it listened properly and gave us this, then what we're going to need to do is unmarshal that set of JSON, right? Now, we could print that out just to sort of see it. I don't know what's going to happen when we play the game, but let's just say that we sort of did that for a minute. Now we've got to unmarshal the JSON, right? So let's take sort of this code here. I'll keep it in here, I guess. Okay, so we define our struct, right? This is our content here. I created a variable called final. Why don't we just do that for fun? And again, if it just fails, let's just do, oops. If it fails, I'll just do this for now. Okay. But if that's the case, then we did get back an integer, right? We should be able to just do response.space. Technically, if the model behaves and just gives us back, I realized too that I don't want to change step 2 here because I do have a reasoning path on there. That's bad. Okay. Now, if everything works perfectly and we get the proper JSON back, this game should just work, right? Because it gets a space, it returns it.
Yep.
All right, let's see what happens. And this was assuming that it's going to listen and behave on the system prompt and everything else.
Loading model.
Okay. That worked that time. We got back JSON there. Apparently, we got there.
It was fast. I didn't even see it.
Okay, my turn. Okay.
Okay, there it is.
So now we know that it didn't bring back a proper JSON, right? Let's see what it did here. It gave us back a string. So this is going to happen. You know this, right? Models never want to behave,
Yep.
even if you tell it to, though it started to do a pretty good job already. Now, this is bad because it said 5, and the logic said the game 5 was already taken, and it wasn't.
Yep.
So
6 was taken, not 5.
yeah, so we have that bug that we need to look at. So we can, we should give that to the model and ask it. Okay, so why did the game logic say space 5 was already taken when it wasn't? Let's just have it do that work. Now, but we got this problem here. So we can start doing some crazy things, right? We can start trying to inspect the JSON to make sure that it's clean, but that's a nightmare because anything can happen at any time.
Yep.
However, Cronk supports the idea of grammars and JSON schemas. So watch this. It makes the model run a tiny bit slower. Oh, and the other problem was, well, there's another problem. Oh, I did disable thinking. Okay, good. So if I hadn't done that, that would have been bad. But watch what we can do to fix this problem.
Schema.
So
JSON schema.
we can
Okay.
define what the JSON schema is specifically and feed it to the model like this. So saying that the JSON has a field name space and it's an integer. This is going to force the model to behave 100% of the time. Slows it down because we're, at the time it's producing tokens, we're,
Yeah. Hey, it needs to be like this.
hey.
Yeah.
But we'll never have to worry about cleaning up JSON again. These things only work when you're not reasoning, because reasoning tokens would have to be looked at as well. So you cannot use grammars.
Okay.
You could use grammars if you write the grammar properly to ignore the reasoning, which you can do.
Yeah.
In this case, I don't necessarily need to be ignoring reasoning here. So I don't know if my change got in there. It just did some bad things on us, didn't it? So I was editing this while it was messing around, so I'm gonna hit save on that. So I'm messing with it while it's trying to do things. So anyway, let's run this even the way it is, and then we'll deal with the other bug. So now watch. We should never have another problem with JSON anymore. We screwed it all up because we went in there after we changed. I should have told it I changed the program, reread it.
Yeah, to get
I
the
didn't do
refresh the
that, right?
context.
So read the program back because I made changes, and then check why game. Let's double check that it's not a problem anymore. Okay, so it made 6 again. This time it went to 4. But you see
But
how we're
it's-
not having errors anymore.
It's not printing out the. We removed the print for the
Well,
JSON.
it clears the screen every time. So unless I tell it not to clear the screen, right? We can just do that for a second. Where does it render the screen? Clear screen. So let's say I just did this for a second. Okay, so
Okay,
it
there.
gave us the 5 perfectly. Oh, but it put
No.
it in 6.
Yeah.
So we forgot to subtract 1 on it for the position. The bug was ours, dude.
Yeah.
So when we return the space, we have to return it as a
Space
-1.
-1.
So we shouldn't have had to, because
Yeah. Why?
we're asking the user. Hold on. We shouldn't have had to do that because. Oh, does read subtract 1? We know we have to subtract 1, but that
Yeah.
would mean yes. Read move subtracts 1. Okay, didn't expect that. Okay, we have to subtract 1. Okay. So that answers all the questions, right?
Yeah.
That we had. It was completely us. But you can see now that the only way this is going to show is if we have an error here. Okay?
Okay.
So
Yeah.
I'll put back the clear screen.
Loading model.
But how quick was it to add Kronk?
That was really fast. Yeah. I mean. Access turn. Okay. Yeah. See, now I put it in 5. Yeah.
So you wasn't smart enough to stop me from winning, though. But it's playing, dude.
It is playing, and it's putting random.
Right? And so it's a model. Does it really know tic-tac-toe, even though it says it knows tic-tac-toe? Like, you know, you're playing a game.
This reminds me of the Connect 4 app that we did. Remember that we had
Yeah.
to train it?
Yeah, we have to train it, right? But this is like, choose a space from the available list that you think gives you the best chance to win. Now, let's do the following, just because we're here, all right? Hold on.
Wonder if prompting it to play defense would
Oh.
work.
Let's see how if Gamma plays better than Unsloth, Gamma 4. Whatever. Let's see.
Oh, what happened here?
Oh, I must have hit the wrong button, bro.
Oh, there we are.
Yeah, I hit the wrong button.
Oh, wait. No, it's still.
This was 2. 1, 2.
Oh, did it get deleted?
What did I hit? Screen share.
It's not. Maybe,
Hold on, everybody, hold on. Overlays.
Source.
Show overlays here.
there it is. I just hit it.
Turned it off. Who knew? It happens. Okay, so now we run it. Now we're playing the Gamma 4 model.
That's 5.
No, not necessarily any better.
I wonder if it's always because it's playing offense.
I
Oh,
just don't think the model. Well, I gave it the win, bro, but I don't think the models really know. Like we experienced this with Connect 4, right?
yeah.
But it's look how well it's behaving with the schema, right? With that JSON schema now, we don't
Yeah.
have to worry about cleaning up.
And that's because of grammars, basically.
So there's pure grammars, and then there's like this JSON schema, which is great. And now we'll never get bad JSON out of the model. It might pick a bad number, but I don't know, dude. It's what the model wants
It wants
to
5.
do. I told it, choose the best space available that you think gives you the best chance to win, right? But maybe we should say, as a priority, choose a space that blocks player 1 from winning.
Yeah, like have it play defense first.
Then
and then, yeah.
choose a space gives you the best chance to win. If player 1 can't win on their next move, then choose a space. Let's see. I don't think it's going to matter, but I should at least be consistent here. Okay. Let's see what happens. But how easy was that to integrate Kronk now with
Now you
the
have
local model running against it, bro? Like, that's, to me, what Kronk is all about right there.
Yeah, that is awesome.
Integrating this into your apps. Okay. Chose 5. 5's not necessarily a bad move.
No, it is a good move. Now it's giving.
There was no way it could. No, I don't think that was a bad move. That was a good
That
move.
was a good
right?
move. It
But I'm
blocked
going to
it.
win. So let's do it again. And then next thing to do is to randomize who gets to go first. But that's fine. See, that little prompt was
Yeah.
important, wasn't it?
Yep. Now I wonder on the next one if you go 5.
No, it blocked as a priority.
Oh, okay. Yeah, instead of trying to win. So it could just be prompt.
Okay. As a priority, choose this place that blocks player 1 from winning, right? If player 1 can't win the next move, then choose a place from a list that gives you best. No, but don't block player 1 from winning if your next move allows you to win.
Yeah. I would maybe reorder
Maybe
it.
it should be the other way. As a priority, choose a space that
Yeah.
choose a
reorder it.
space that allows you to win.
Yeah.
If you can win on your next move.
On next move or current move?
On your
Current. I think it would be current.
current move. And second, as a second priority, as a second priority,
Winning. Yeah.
see, I don't need, oh yeah, if player 1 can't win this, then choose a space from the available chance to win in the future. Don't,
If your next
we
move.
don't need this anymore, right?
No. Yeah.
All right, let's see what happens. I feel like Gemma's playing better than Quen, isn't it?
I think so. We also changed up the prompt a little bit, but
I'm gonna go 9. See what it does.
ah,
So it didn't choose to win there, did it?
no. I wonder why it.
Who knows? It's just tokenizing. Like the fact that it's even behaving this well is already sort of stupid, silly, isn't it? That it can even reason on this small little set. But I like this little prompt. We're gonna have to keep this. I'm gonna keep this for. I have this here just in case I'm on stage and things go
Yeah, haywire.
sort of haywire quickly, which they will, because you saw how long it could take
Yep.
to generate that. Anyway, this is sort of part of the talk that I'm doing on stage. It's look how easy it is to sort of integrate Kronk now into these apps, like doing this. And, you know, hard coding where the models are, we obviously have tooling to help you with that, but
Yep.
But
No, that is awesome.
it's pretty wild, man.
That is cool. It's come a long way.
Yeah, no, it's ready for prime time here now. So we don't need this here anymore. Get rid of this. And the only changes, we don't need this either. So we built a main as part of its work. I always try to tell it to clean up, but it doesn't. And now at least what we've got here.
Says there's 2 changes.
Yeah, I'm just changing the prompt on those things. Just fixing the prompt. Okay. Pretty cool. So at least in the last, and we're at the end of the top of the hour, so that's good. We did an entire, not an entire tour, but a decent tour of where Kronk is today, version 1.2.4. And running these 2 MOE models. which is pretty wild. Now I've got those two machines in the other room, the M3 Ultra and the M4 Max. And next thing for me to do is turn those on and see if we can run some large dense models on that, cluster them together too, and then see if we're getting closer to frontier level programming. Like these models program as well as I do. I was on the plane and I made a bunch of refactoring and I used the Qwen 3.6 and we did a bunch of stuff together and I was happy with the code. And then I asked AMP to look at it and it found a whole bunch of things.
Oh.
And I realized that these models were programming about as well as I can, but the frontier models are programming better than me at every level.
And by frontier, you mean like the cloud model, like Anthropic?
Yeah, all the models that are running up there, call those the frontier. We're not there yet locally, but we are at least at a human level, I think, programming locally at this point.
That is pretty cool.
Which is pretty wild.
That is awesome.
Okay, so on Thursday, we're gonna start building some stuff with Kronk. Start thinking about real apps to build, and that's what we'll do on the show. And if we find bugs like we thought we found today, then we can run through that stuff, and it will be good for us to also validate that things are working. There isn't much left for me to do in terms of, other than the, hold on, kill this. I have this, actually should make sure that this all, give me a check there, good. This is my current sort of list here, and everything else is pretty, like, nothing I really have to do at any level. I do have to go back and look at the speculative decoding stuff. That allows you to use a draft model to try to speed your model up by letting it start to produce some early tokens and sort of guide a larger model. It's a way of speeding up a big model.
Interesting.
We haven't played with it enough, so I don't know how good it is right now, but I don't think it needs to be in the VRAM calculations. So these are silly things, but now that we've got the machines, this I'm just going to get rid of. I don't need this one anymore. Oh, by the way, look at this. I got 4 more minutes left. Watch this, bro. Let's have it build tic-tac-toe one more time, just to give it something to do. Okay, watch this. Oh, wait a second. Watch this. I thought it was composed, but... watch this.
Grafana. Oh. Oh, you're in the talks.
It would help.
If we were running Docker.
Docker.
I do that at least once a day.
I don't like leaving it running if I don't have to. Okay, I got Grafana running, all right? Have it do that. Have it get busy. And then I did all this work too.
Oh, that's cool.
So we've got full dashboards on traces, stats, model timings, token throughput, TPS, VRAM usage. Because you're running Kronk, we've got the resource manager budgets, where you are in the budgets, like I saw on the browser screen. Pool stuff, chat requests.
I love data.
Dude, this is insane, right? But I couldn't have done this without AMP, because building all this stuff is insane. But
that is cool.
Yeah, it's building that out. So we have this. I would have thought we had some traces already. So I wonder if we broke that. Or we started the server. Yeah, that's probably what's happening. I started the server first and we didn't see it. So we're not pushing traces. I need to start this first. But
Okay.
this is crazy. Huh?
Reasoning completion.
Yeah, all this stuff is built into the server. You get all these dashboards and all the important numbers if you know how to. Oh, we got a trace.
Trace ID. Whoa.
Like the prefill generation. Yeah, man. You get
Microsecond.
all this for free, so you can start. Yeah, got traces coming in.
That is cool.
Yeah, no, I spent a day on this. So you're not blind to anything that's going on when you're running the Cronk model server. Now, this is part of the SDK. We know when when the stuff isn't turned on, so it doesn't cost you that it's in the SDK. I've made sure of that. If you didn't set up an hotel collector and all that stuff, it all gets sort of ignored. We have no ops, so it doesn't cost you any performance. But if you do turn it on, you can attach this to your own dashboards because it's all in the SDK already too. So you get it all for free. It's just about sort of wiring it up if you don't. And obviously the project has all the wiring. So I don't know. It's pretty wild stuff. Anyway. So
That is awesome.
let me shut this down. So for everybody that saw that, you're getting all that for free as well. Stuff that Florin loves.
That is Florence home.
Yeah,
Right there.
and I'm gonna stop you. Shut you all off. And I'm assuming that you wrote some code already, and you did. So clean that up. Okay, so you saw that now too. Everybody has it. So when we get, I know it is crazy.
It is.
But this is what I've been doing. So when we get back on Thursday, we're gonna start building some stuff using Cronk, and we'll leverage these examples as guidance. And I want people to start building with it. And there isn't really, you saw my issues there. There isn't really anything else to add to it other than the ability to run models clustered across those machines, which is sort of the next step.
Yeah.
Everything else on that list was sort of whatever. So it should be super stable now at 1244, 124.4, and we'll start building some stuff, man. I'm excited.
No, that's awesome.
All right, bye. See you on Thursday.